In part one, we learned how to solve exponential and logarithmic equations that had the same base on both sides of the equation. In this video, we'll learn a more general way to solve that allows us to solve a little more complicated equations. Okay, we're going to use this property that we've already learned. We've already done some converting from one form to the other. Okay. We can use this property right here, exponential form, log form, right? How we define the logarithm. So I'll have that on each slide here because we'll use it every time. We need to be able to go back and forth. So for solving logs, we may have to go to exponential form. For solving exponentials, we're going to go to log form. All right. So let's take a look at how that works. Example 1. If I want to solve that equation, natural log of x equals 2, it may help to convert it to the equivalent exponential form. Okay. So we start with the base. What's the base of this logarithm? That's the natural log, so base e. This guy's the exponent, and that's equal to x. So I go something like that, right? And that's my conversion. That's my answer. Now, throughout this video, we're going to get 2 ways to write our answers. The exact form, which is what x equals in this case, e to the second power. That's the exact solution. But we also have to be able to do decimal form for any answer. So for some of the problems, I'll give decimal form. For some of them, I'll leave them as exact. This one I'm just going to leave as is. To get that decimal value, you just plug that into your calculator, e squared. Number 2, okay, so I should mention before we apply that property that I have in the upper right-hand corner, I need to always have the log or the exponential isolated. I need it all by himself, the log expression. So in this example, I'd have to do one step in order to do that. And if I add 3 to both sides, I'm now dealing with log base 5 of 4x minus 3 equal to 5. And then I apply my property. Start with the base, raised to the power, and it's going to be equal to that, right? So that's going to be 5 to the 5th equals 4x minus 3. All right, we could raise 5 to the 5th. That's a big number, so I'm going to leave it as is. Plus 3 plus 3. 5 to the 5th plus 3 equals 4x, and then of course divide by 4. Okay, and there's my solution for x. Again, I could figure out what 5 to the 5th is, add 3, divide by 4 to get the decimal value, but I'll leave that one. At some point I'll give you some decimal values, okay, soon. All right, so keep going. So in this case, number 3, I have the same type of problem here. I just got to convert base, power, equals input of the log. Minus 5, and I get x equals 4 to the 1/2 minus 5, which I know how to deal with. This one's an easy one to do. 4 to the 1/2 is the same thing as the square root of 4, which is 2. So x equals 3 negative, or negative 3. Okay. Again, we want to check these answers. I got a negative, so I'm thinking, well, wait a minute, is that going to be okay? But if you plug in negative 3 there, you're good, because negative 3 plus 5 is a positive value, and the log base 4 of 2 is equal to 1/2. Moving along, special base here, log, there's no number here, so we understand the base is 10. 10 squared equals what you're taking the log of, 2 minus x, and that's 100 equals 2 minus x minus 2 minus 2. 98 equals negative x, making x equal to negative 98. And I could check that, but when you plug in a negative 98 here, you get 2 plus 100, and the common log of 100 is definitely 2. So those are examples of log. So I was going this way, right? I was given the log, and I went and put it in exponential form to solve. So we also have to be able to do the opposite. go from exponential form to log form, right? So my first example is the easy case. I go log base 5, right? The bases are always the same, and the inputs and outputs are reversed, right? This is the output for the exponential, so it's the input for my log. This is the input. I'm sorry, the x is the input for my exponential, so that's the output for my log. Or in other words, the variable up in the exponent is what the log is equal to. Okay, good. So now I have a solution. X equals log base 5 of 12. If I ever want, let's do the decimal for this one. If I ever want a decimal value for this, then I can use the change of base formula, which we've seen before. Okay, so that's log 12 over log 5. I'm allowed to use any log base for change of base. This one goes on top, this one goes on bottom, and I'll use common log, right? Or natural log. Those are the guys I can plug into my calculator. Okay, so if you want to practice with your calculators, you would type this in, see if you get the same result, log 12, and you're going to divide that by log 5. It should give you a value of 1.54. Okay, approximate solution, exact solution. Be able to do both. All right, plus 5, plus 5. Remember, we got to isolate this exponential expression for number 2. I got that. I want that by himself. So 3e to the 4x equals 15. Then divide by 3. So we're just doing kind of basic algebra here. And finally, I've isolated my exponential expression, right? E to the 4x is my exponential expression. Now go from exponential to log form. So the base is e, so for log, that's the natural base. That's my input. That's my output. Okay, and then to solve for x, I would just divide by 4. All right, and there is my solution. The natural log of 5 over 4, I'll leave that one as exact form. If I want that in decimal form, I just plug that into my calculator. All right, 2 more. Okay, so we'll call that one 3 and that one 4. All right. So what I want to do is isolate, again, the exponential expression. So that gives me 3 to the 3x minus 4 equals 7, and then apply my property. I have an exponential. I want to change it to log. So it's log base 3 of 7 equals 3x minus 4. Okay. If I want to leave this in exact, I'm just going to leave that expression there. In order to make that a decimal value, I use my change of base formula, right? It would be log of 7 over log of 3. I plug that into my calculator. I can use the common log or the natural log. If I want it as exact, I would have to leave that expression in there. So let's come down here. That's the log base 3 of 7. And then I'm adding 4. And then finally, I'll divide by 3. All right, and that funny answer is what my answer is. Okay, that's how I'm going to write my exact answer. Now, if I want that, again, as decimal, I'd have to use the change of base. And to get the change of base for that one, or to use change of base, I would just use that here and get the decimal and then add 4 divided by 3. Okay, so I'll leave that as exact. We'll do the next one. We'll get the approximate answer for the next one. Divide by 1,000. So I got 1.05 to the 3t equal to 10. Apply your formula. What's the base? This has a funny base. Log base 1.05 of the output equals the input. Divide both sides by 3. There's my answer. Okay. So t equals the log base 1.05 of 10 over 3, but I want that in decimal form. So again, we're going to use change of base just for this guy. Change of base formula goes like this. the natural, well, let's do the natural log this time. Doesn't matter which log I use to change. I'll do the natural log of 10 over the natural log of this base, 1.05. Okay, that's how I get this guy with circled in red as a decimal value, and then I divide it by 3. That will give me the approximate answer, which we have to be able to do sometimes. All right, if I plug that into my calculators, you should get a t-value of 15.07. Sorry, 15.7.